Hello, everyone, and thank you for joining me. This is a session by Mend.io, application security company, and we're gonna talk about how to do security and implement security in 2026, especially in code and in applications. We're gonna look at it in a strategy and execution perspective, like what we can do about things, what are the new things that we need to deal with. I'm glad to be here with you, Amit Chita, and let's go. Let's start talking about it. So there's few major changes that's happening right now, but I want to focus today on three of those. And the three are that now AI is writing code, and as application security professionals, it's gonna change how we need to secure code. Secondly, AI becomes part of the attack surface, which means that we are building code with AI and shipping applications with chatbots, with LLMs built inside them, with agents. Now we're serving our customers with these agents, and it has implications of new security things we have to deal with. And thirdly, is that because of AI, everything is now moving faster. So attackers are moving faster, and we as defenders need to figure out ways to move faster as well. So we're gonna now dive into each of those, see what is changing, think of strategies, what we can do to tackle this, and then we'll go into the tactics of what can I do tomorrow in my organization to improve the situation. So let's start with number one, AI becoming a code producer. So now developers are no longer writing code like they used to. They basically, in most organizations, use agent IDEs. And in these IDEs, the developer will ask a prompt, the AI, develop this and this feature. No, change that, change this. Why did you do like that? It's a conversation rather than a development like it used to be. Now, of course, this is different between organization to organization, like early adopters, all the developers will do it already. In organizations that are a bit more slow to adapt, you're gonna see developers still doing the transition. This is changing things, right? It's no longer the developer writing any line of code. They hopefully reviewing every line of code, right? But it changed all the security aspect of it and also the effort that is taken to fix vulnerabilities. Now, if we try to anticipate where we're going, we need to first look at where we've been from. So developers used to write code manually, write any line of code, maybe with basic auto-completion. And then we started to see AI auto-completion coming. So when a developer will start to type a line of code, the AI will complete it for 2, 3 lines of code, even a full function automatically based on smart completion. Then we did a jump to where we are kind of today, where you have an agent, you ask the agent to do a task, it changes the code, and you continue the conversation. But looking forward, we're gonna see a lot of prompt to pull request, right? Or merge request, which means AI will develop the full feature and will submit a pull request to the GitHub. So we don't even gonna have a developer in the way for certain tasks. Or the developer will only be a reviewer that will look at the differences and will look at the pull request and add comments. And the AI will gonna comment on that, and you're gonna have like senior engineers that are AI, or junior engineers that are AI, and senior engineers that are people that are reviewing this code. And this change, like it brings us challenges, right? How can we trust the code that we have now if it's written by AI? Right? Is it the same as a human? Is it more secure, less secure? Does it even matter? Right? Now also the development is faster. So security is expected to be faster. So I can't now hold an AI developer to do tests for hours if it closes an iteration in 5 minutes. right? I wanna increase the speed of the test and closing the security iteration as faster as I can and do it before the code is even in pull request. How do we reduce bad security practices? So in developers, we used to train them, to tell them how we expect them to write code. We had like company policies, we had onboarding for new employees. How do we do it with AI? And at last, an issue that we need to think about is all these coding agents that now write code, they can be exploited. They can be convinced to write bad code, to expose company data. They can be a jailbreak point into our company. So let's start to explore strategies to deal with this. The first strategy that is fairly interesting is the zero trust approach for code, right? So this is not new. Developers are writing vulnerabilities, they're inserting malicious packages, they're exposing secrets, and any good security person know it already, right? And we don't really trust the developers. We put in the pull request and the merge request check runs to test for vulnerabilities, to test for 0 days, and hopefully to fail the build. But as we see as a security vendor and working with hundreds and thousands of companies, that most companies don't really enforce today their policies. Why? Because let's say like not all the time, the check runs are optimized to fail only for the things that we want them to fail. And also not all developers will agree to that, and it becomes a conflict between security and the development. So you have the check runs, they will fail when there is a vulnerability, but we don't enforce that you can't merge the code with vulnerabilities. Now, this is something that has to change in 2026. Now that a lot of the code is being written by AI, and it's also easier to fix vulnerabilities, there's no reason not to enforce policies, right? And we'll talk about it a bit more. Another strategy is to align the coding agents with security guidelines, right? So basically to adapt the system prompts. We're gonna talk about this a bit later as well. We're gonna try also as a strategy to let coding agents handle the fixes as much as possible. And then we reduce developers' frictions, right? And in the tactics, we're gonna explore ways to do it. And the last strategy that I want you to think about is employing principles of least privilege for developers. So if until today we didn't trust a developer, but we had a contract with this person, we can fire them, we can sue them. We can do the same for AI agents. So we need to reduce the amount of permissions in the repositories for these AI developers, which is a real developers, right? So let's dive deeper a bit into the things that we can do, right? Enforce our check runs in the repos. Make sure we have security check runs. Make sure we configure them well and the policies of when we want them to fail, and enforce it so no one will be able to merge the code without the security passing or only with special approval, right? Of an admin, of someone with permissions. This is the basic for 2026. Secondly, we have no great opportunity because AI IDEs can take special prompts. We can start populating security prompts within the organization. The way I like to look at it is similar to training of developers. So in the past, we had to train developers to know about security issues and to understand how to write codes the way we want it security-wise. But now we can just build once a prompt and populate it through the IDEs of all the developers in the company. This prompt can talk about bad practices not to do, how to manage secrets, how to manage authentication, and things like that. And all our coding agents will just become more secure, which is amazing for us as security people because it's value that we can get without needing to trust people here, right? We need to trust only the AI, or at least help it do its work better. Now, how do you populate that in a huge organization? So what's nice about it is that either Copilot or Cursor or Windsurf, they usually support configuration files within the repos. So you can populate configuration files within the repositories. Write one-time automation in the GitHub that write this configuration file to all your repositories with a specific prompt for all your IDEs, and automatically any developer that will open the repo with Copilot, for example, will get these prompts, these security prompts that you designed. It's also a process that you can do once a quarter, maybe update it twice a year, I don't know, and make sure that you're on top of the best practices of security for your coding agents. This is a huge opportunity for any security professional right now that wanna at scale improve the security of the code base. Now, another thing that we can do, and another layer we can add on top of that, is adding MCP integrations for security within the coding assistant. So, for example, something that we did at Mend, but there's other options out there if you need, is we wrote MCPs that give the agents tools like, hey, check this piece of code for vulnerabilities or bad security practices. Hey, can you tell me if this package is good? Is it malicious, right? Does it have critical vulnerabilities? Maybe there's a better version I can use. And what will happen is the agents will start to use these tools, right? You can also prompt them to do it, but they will also automatically start to use the tools if the tools are configured correctly. And the agent, instead of just installing a package that it needs, it will then be like, oh, wait, let's check with Mend or with whatever security tool if this package is good for me. And it will check the package and be like, oh, I need to upgrade to a different version because this one has vulnerabilities, and it will upgrade. And then you're closing a security loop while developing. The developer has to do nothing here, right? Not the fixing, not the identifying, because the agent will do everything, and you just close the loop faster before you get even to the pull request stage. This is a huge win, and I think the way to look at it is even if such MCP tool enhances the security of the code by 10%, it's a 10% that you can get across the whole organization. And it's a major change because it's kind of free for you. It's free because it doesn't require any developer resources. It does slows a bit the development, but tools like that are built correctly should run really fast, and it's not like a whole static analysis scan that runs over all the code, and it should be something very minimalistic and efficient. Now, I want to now jump to the next topic, right? The new attack surface that we have now because of AI. Let's explore what is happening right now. We have new technologies in the tech stack, in the code base that people are using, right? We have AI notebooks, we have inference providers, right? So we're now working with OpenAI, with Claude, with AWS, asking them to run models for us. We have now the models that we have to deal with, right? We're dealing with different models that a developer might use in the code base. Some of them might be also open source that they download locally into the repo from Hugging Face and just running them locally or running them from the container image. And on top of that, people start to build agents, connect these agents to tools, so APIs, and then the LLM has access to different APIs. And of course, there's other new technologies, but this is just to start and like to think about what is changing. Now, with these, we also have new kinds of vulnerabilities. There's the OWASP top 10 LLM vulnerabilities. There's also now been launched a few days ago OWASP depends when you listen to this, but ops top 10 for agents. Now, there's one thing I want you to notice here. A lot of the issues here come from prompt injection. Prompt injection, for a reason, it's the number one in the OWASP top 10. And basically, the core of the issue with LLMs and agents is that they can get convinced to do something you didn't want them to do, right? Someone can get a text into your agent that convinces it to do something bad. And this is something now we have to deal with because until now, software were like it was pretty static. There were logic, we can find the edge cases, but now we have an agent, it's connected to tools, it can be convinced to do stuff, and you as a security person need to make sure that you like can handle that, you know how to test for that, and you know how to limit that. And we already seen attacks happening and proof that people can get data, right? Even cause a code execution using a prompt injection. So it's not theoretical, it's a real issue. Uh, Everyone is working hard to solve it, and it's an unsolved issue in a lot of cases. And we as security people have to do it as well for our own organization. Now, this problem of prompt injection can become even more problematic when we have tools. So the tool itself might return a content for the agent. Let's say I have a tool to read a website. So the agent will read the content of content of the website, and we look at it. And the text within the website might contain a prompt injection, right? So any tool now that we connect to an agent becomes an attack vector to our agent. So if we built an organizational chatbot and we connected it to tools, now we need to think about every tool. Is it possible that somehow a malicious prompt will get into the content of the tool? Or so every tool becomes a way to exfiltrate or like get data out of the organization, right? Because if I have now a tool to send an email, right, to write a file, I can leak sensitive data from the organization using that file or that email. On top of all of that, we have no regulation, right? So it's not only that if you care about security in the organization, there's things that you have to do. And this is still the early days, right? We have the EUAI Act, which mainly talks about bias and misinformation, and you having to check your chatbots, especially if there are critical things like insurance and finance, but not only. GDPR covers it already, right? Just with protecting your PII. And there's now coming in 2027 the Cyber Resilience Act, which basically asks you or tell you that you need to test your AI chatbots for all kinds of vulnerabilities and to make sure that they're okay. So these are the things that are here or Cyber Resilience Act to expect, but there are more coming. And this is how at least I look about these challenges, right? The compliance here is hard. We have new licenses for the chatbots, right? It's hard now because we need to detect and protect like all the chatbots that we have against prompt injections. There's even denial of wallet attacks, right? So people can use a lot of tokens of your chatbots or of your AI and like drain the budget of your company. There's like how do we do policies around the organization? How do we enforce these policies? Uh, Things are interesting, right? This is the biggest new space for us to learn that is not the traditional security that we used to do, but there are a lot of similarities. So here are the tactics that I recommend, like, or approaches that I recommend, but let's start by looking at the strategies. First, staying on top of any use of security within any use of AI within the organization. So the first thing you want to do if you want to secure your AI is just know who is using AI. Now, if you're like a 30, 40, 50 people company, this is easy for you, right? You probably know it's one team. There may be your friends in the office. But when we're coming to organizations that are thousands of developers, tens of thousands of developers. They have so many repos. how do you know, right? How do you know who's using what AI, what provider? How do you enforce a policy? We're going to talk about that. You need also to identify all the risks. You need to test your chatbots. You need to test your LLMs. You need to also review them, right? And we're going to talk about this as well. And in the end, you need to find a way also to mitigate the risks. You need to have a plan of how do you mitigate these risks. And I'm going to talk through a few approaches, including hardening prompts and adding guardrails to your AI chatbots. So let's start with the inventory, right? This can be automated, right? That's the easy part. You use a tool that scans on all your code repositories, finds all the usage of AI. Now, what you need to make sure that you find not only usage of AI through AI providers, but also AI that just run manually. So if you have code that downloaded a model and running it locally and not paying for inference for third-party providers, that you can find this as well, detect it, and understand what is the license, right? And what's the compliance of that. On top of that, you should make sure you have some way to define policy. Let's say I want to say that specific models are allowed within my organization or specific AI providers. How do I enforce that people don't insert new code into the organization with models that doesn't fall within the policy? We need a check run for that within the CI/CD, and we need, like we talked earlier, right, to fail on that check run. So make sure that you have a tool, either a tool or an automation that you build that will allow you to do that, to understand whether a piece of code is using an AI model, and then to enforce your policy of whether you allow it or not within your repos. Here we come to the topic of LLM red teaming. So this is today the common approach of how to test chatbots. And it's a bit of a brute force or a fuzzing-like approach. We have a chatbot and we have another program connected to the chatbot trying to break it by having hundreds or thousands of conversations, trying to find all the edge cases, trying to see if things like the AI Act would want, right? Like bias detection, discrimination, resiliency, that it doesn't talk about legally binding stuff, but also security, whether this like LLM or agent can execute code and can be used to execute code. Maybe, I don't know, you have like a payment service and a payment chatbot, and you want to make sure that the chatbot doesn't allow payments that it shouldn't, right? Because of the functionality of the product. You need some way to test it, and today the standard way is to apply LLM red teaming to your chatbots. There's all kinds of tools for that. It shouldn't be manually. It should be manually, and it can be manually because you need numbers. You can't really test all the edge cases. So you need like huge numbers of trials and then see, oh, for bias, I'm failing 10 out of 300 tests we did. Okay, and then maybe next deployment, you're gonna fail 15 tests out of 300 and be like, oh no, the situation is getting worse. Something that we changed in the chatbot, whether it's the prompt or anything else, caused an issue for me. The last part, which honestly I think is the most important, is to review your agent, right? So today still for the issue of indirect prompt injections that come from the tools, we don't have a perfect solution. And what I would recommend is you knowing about all the agents that developers launch within your organizations and have some process to review them. And today, this review should be still manually, right? But in the future, as the market matures, this should be automated as well. And this review should be things like, hey, what agent is there, right? What tools this agent is connected to? wait, I have an agent that is connected both to Salesforce, like here in the example, and both to the email. So possibly this agent can take information from my private Salesforce and send it in an email to someone outside my company. That's bad. That's a security issue. And if it's possible, we should assume that it will happen. Right? So then we need to come to the developer, figure out whether the email tool they added, whether it can send emails to anyone or only people inside the company. We need to try to figure out what are the security issues with this agent. And we should start doing this with any new product line that is LLM based that we have. And here it ties back to having an inventory and being able to tell if it's a large organization. On top of that, something that is very important is to also harden our prompts. The way to think about hardening our prompts is so you're not gonna solve the issue, but you're gonna make it much harder, right, on an attacker to exploit you. So you want to make it hard on people to do a prompt injection. So by explaining to your agent that someone will try to inject it, right? Explaining what is user input and what is not, what is the commands and what is not. And there's all kinds of techniques to do it well. We can reduce dramatically the easiness of doing a prompt injections. So attacker will have to work really, really hard to find a prompt injection that works on a hardened prompt LLM. And of course, guardrails. You will need also to put some runtime checking, right? And to try to drop communications. And not only communications with the user. So usually when people think of guardrails, they think, oh, let's drop certain of the responses of the agent if we think they're not good, or let's drop certain of requests of the user if we think they're not good. But that's not all we need. We need also guardrails for the tool calling, because as we said earlier, we can't trust the tool. A web search tool can return for me text from the web that contains a prompt injection. I need to be able to drop that. A request to a website in the URL can contain data that is leaked. I should be able to drop that as well. So we need guardrails both for our tools and both between the user and the agent. And now let's jump to our a third part of the day, speed, right? How do we handle the changing speed? So first to prove what we're talking about, we have here time to exploit data of CVEs. And this is basically showing us that in 2024 already, this time was negative. What does it mean? It means that attackers are exploiting vulnerabilities and using them in the wild on average before the CVE is even released formally. So it means we, our defenders, find the vulnerabilities so slow that attackers are already starting to exploit them. What do we do with it, right? How do we, even if it wasn't the case, even if it was one day, right? Who do you know who fixed a vulnerability within one day? This is really hard, right? And to do it, we have to have prioritization in place. We have to have a way to automate things. We can't do things manually anymore. And we see this also more and more advancing. We see that Anthropic, they launch a research showing how AI can automate vulnerability findings with a lot of agents. I think that your attackers, right, right now, they're not your attackers, but the attackers that are potentially will attack your company right now are running agents, trying to find new vulnerabilities, trying to exploit new organizations. And this is not all in theory. People prove that it's possible and it's already happening. So how do you fix vulnerabilities fast enough? How do you reduce the attack surface, right? Because if attackers are so fast, we need to reduce the attack surface in advance and not trust that we know about all the CVEs. And in general, how do we make it harder to exploit our organization? So There's two main strategies that I would recommend for 2026. A, and of course, automate everything you can, right? Updating of dependencies, automate it. Vulnerability fixes, automate it. Doing security tests, automate it. Leave the least as possible to manual processes. And the second strategy is, of course, to harden your environment. There's a lot of options here. The three I chose to mention is to harden your container images using hardened compilers, which is basically, I think, enough. It's better to use new compiler versions. A lot of times, the newer versions have like a lot of security issues, security capabilities built inside, and web application firewalls, runtime protection. You should protect in both sides before the code is in production and after the code is in production. Uh, let's dive a bit into the tactics. Automating the dependency update. So there's tools like Mend Renovate and which is similar to GitHub Dependabot that you can configure to automatically update your dependencies within the repos. This is super important. You don't want to have a lot of unmaintained dependencies. It's really like when you have a vulnerability, it's really hard to update a package that is from 5 years, right? And you didn't update this package for 5 years. But if you update this package every week, so only once in a while you'll have a version that will break something, you need to do a minor change. But to change after 5 years, usually it like have higher chances to break your code. And you don't have the knowledge of how the repo works anymore. So you want to have some or process plus automation for updating dependencies. You can also do all kinds of stuff. There's technologies that allow you to know in advance which updates will break your code, which will not, and then you can automatically update the things that won't break your code. And uh, you should consider all these approaches and make sure that you have some setup that you're happy with to automatically update stuff and automatically fix vulnerabilities, right? Ideally, you want automated PRs within your repos for fixing the vulnerabilities that you have. And we want to make sure that the developers review it. You want to make sure that you have proper tests, because if you have proper tests, the developers can trust these automated PRs and they can just merge them. And that's the approach for 2026. And if you don't have it until now, I strongly recommend to set up something in place. Now, when looking at hardened images, I just want to mention that there's a lot of vendors today providing their own hardened images. You can also do it on your own. Some companies have their own image management team that you have maybe your own golden image. I will just mention the CIS benchmark. They have great benchmarks and they will literally tell you what commands to run within a VM, within an image to harden it. So let's say you're using Ubuntu images. There's the set of commands to run there, highly recommended. Uh, what I talked earlier about compilers, I just wanted to show you that a lot of security features comes in newer compilers. And if you still use, and it's not only compilers, it might be also a framework, right? If you use an old C Sharp, an old .NET, or an old Java, or an old GCC, you might be much more vulnerable than a company that update these all the time. And there, the shifts are major, right? There are security features in newer compilers and newer Linuxes, for example, that make it super hard to have a Stack Overflow, right? Because there's a shadow stack feature that they're using within a newer Intel chips, right? And only new compilers know how to deal with that and to add the extra instructions. So this is a major thing that you can do. I know for a lot of organization, it's hard to do this change because this will break your code and then you'll need to fix it. But you should definitely have in 2026 a process in place to update this. It might take months, it might take a year, but still important. I want to just summarize the three things we talked about. right? Because I feel like we talked about a lot of things. A, AI is now writing code, right? We need to adapt to that. There are things that we can do to secure that. We can populate prompts for our AI. We should make sure that we have policy in place and it's enforcing the pull request because more code is written by AI. Now also the attack surface is bigger because we're putting AI in our applications. We have chatbots, we have models, agents. There's compliance issues with that. We need to test these for the new kinds of vulnerabilities. We need to do some protections, to do some reviews for our agents within the organization. This is something that currently we'll have to do manually, but we'll want to automate looking forward in 2027. And attackers are now attacking us faster. So in general, we need to figure out way to A, fix faster, have automations in place, and B, reduce the attack surface, have as many defenses as we can and as many easy hardenings as we can to make it so even if there's some vulnerability, it will be much, much harder to exploit it. That's everything I wanted to talk for this session. I want to thank you everyone for joining me. I hope you'll have a great 2026. I think for application security professionals, there's a lot of opportunities to learn, right? We see a lot of new kinds of technologies, new kinds of vulnerabilities. We have a lot to learn, but also we have a lot of challenge in our work, right? Things are changing all the time. I think it's the hardest it's been to protect an organization, but it's also exciting, right? It's exciting that things are hard and we have challenges to tackle. So thank you, everyone. I'm Amit Chita from Mendayo. Come join us in January. We'll have another talk, another webinar. We're going to talk about system prompts and how to secure them, prompt hardening, dive a bit deeper into that. If that interests you, we would love for you to join. You can use the QR code here. Thank you and have an amazing 2026 and good luck to all of us. Bye.